with two portion means one portion Rafiq sir will teach you and another portion I will teach you. So the second portion I've got, and that is power. Work power energy মধ্যে power portionটা তোমাদেরকে আমি পড়াবো।
না ক্লাসে ব্রেকে দিছে।
Okay, so we can start from here now, and we will go for power. But I can give you some information about work and energy. Then I will go for power. Okay. So first, we give our heading as power. As power. So okay, now we start. Work done of an object per unit time is called power. Work done of an object. All of us should write this. Work done of an object per unit time is called power. Per unit time is called power. It's a simple definition. If I say what is power, you can say it's the ratio of work and time. It's a simple equation. Power is equal to work divided by time. Or you can say also energy divided by time. Because work and energy are the same format. If you have energy, you can do work. So work and energy can be said as it's a similar conversion. No different conversion between work and energy. But if we talk about power, then we have to get the rate of it. The rate of work done is called power. Suppose you are going to the upward by stairs. Your building is 5-stair and you are going 5 stories building and you are going to the upward direction. Suddenly you need to go your flat in a hurry. Then you just run with the stairs and reach your flat in, suppose you reach in your flat in 1 minute. And in normal time, you reach in your flat in 2 minutes or 3 minutes. So here you will use more power when you reach in your flat in 1 minute, because at that time the work rate is higher. So when we discuss about power, you have to remember that the energy that I used per unit time is called power. So what will be its unit? If I say work has a unit of joule, you know that, and time has a unit of second. So power can be said as joule per second, and you can also say it in this way, JS minus 1. It can be said as watt, W. So watt is the unit of power. You can see this, power actually is the ratio, and if I say ratio, it can be said as joule per second. Joule per second can be said by another name, which is watt. So the unit of power is watt. Okay. And if I want to get the dimensional equation of it, so what we can say the dimensional equation. I will go on the right side. If we have work dimensional equation, it's ml squared t minus 2 is the work dimensional equation, and the time, the dimensional equation is t. So therefore the dimensional equation of power becomes like this, ml squared t minus 3. So this is the dimensional equation of power. Okay. So the last part, what is its equation? If I represent power by P, work by W, and time by T, it's an easy equation. that equation is P is equal to W by T. Okay. So for the power explanation, we have got some quantities, its equation, its dimensional equation, its unit, lot of things. Okay. So first we will go for a math as we see a equation, a very small equation here. So we will go for a small math, in fact, which you can solve in your objective exam also. Okay. The first math here it comes. An object works 3 kilojoule in 1 minute. An object works 3 kilojoule in 1 minute. 3 kilojoule in 1 minute. What will be its power? An object works 3 kilojoule in 1 minute. What will be its power? What will be its power? So it's an easy equation. You are given W as 3 kilojoule, kJ, but you have to convert it on joule because kilojoule have to convert on joule. Joule is the SI unit. And also your time is given as, you have time 1 minute, which is 60 seconds.
Sir, 50 watt আছে.
50 watt, right? It's a very easy one. 50 watt is the answer. So the first math, we have got an answer which is 50 watt. Okay. So if we talk about power, we have to remember just one thing clearly. If I determine the work done or the energy used by an object, I can easily get the power. Because if I get the value of work done or energy, just I divide that work done by time, I can get the power. So power is very easy if I get the work done first. But what will be the equations for work done? The work done equation, which we will taught by Rafiq sir, W as Fs. Now I am giving you some explanation of work. I am on the power topic, but I am giving you some explanation of work done because work done is necessary to solve the power. Okay. So W is equal to Fs, which is the product of, actually you can say the product of force and displacement. So if I say what is work, you can say it's the product of force and displacement, but not in the definition. If you are saying this in the definition, you just get a 0 mark. The product of force and displacement is called work. It's not the right way to say a definition. So what will be the work definition? I'm just giving you the work definition here. So write it, the work definition. When force is applied on an object, when force is applied on an object and it makes a displacement towards the direction of force, and it makes a displacement towards the direction of force, is called work. Okay, I am repeating again. When force is applied on an object and it makes a displacement towards the direction of force, is called work done or work. So you have to remember this thing. Work is the product of force and displacement. Okay, now force can be say in several forms. Suppose if I say force F as ma, if I say force as ma, then W can be said as MAS. If I say force as mg, then W can be said as mgh. So these are the things we have to remember when we're doing some work done, the value of force. If something is going towards the horizontal line, just like a car is moving, an object is moving in the horizontal path, at that time you can consider the force as ma. But when you're taking an object to the upward direction or to the downward direction, then at that time it's not the horizontal line, it's on the vertical line. At that time, F can be considered as mg. That's why the height is here instead of displacement s. So these are the things that we have to remember when we do some work, when we get some work done, before we derive the power, before we get the value of power. Okay. And also, if I say energy, I am giving you a small explanation because RIP sir will give you the all of it explanation, work and energy. I am giving you just the power, but if I want to teach you the power, then I have to focus these two again. That's why I am now going for energy. It's a small explanation because when we are doing some math, we have to learn these two things. Energy. So if I talk about energy, I said it before that work and energy are the same thing. If you have energy, then you can do some work. Or you can say, when you're doing some work, you must have energy. So this way, in these two ways, you can say that these conversions are similar. Those are similar. Okay. So if I talk about energy, what is the definition of energy? Definitely the definition of work and the definition of energy are not same. The energy definition is a very simple one. Not like work definition. It's a very simple one. I'll tell you, you will just write. The ability of doing work of an object is called energy. The ability of doing work of an object is called energy. If you have ability to do some work, it is energy. It's a very easy format. So, if I talk about energy, then it can be further classified into two. One is potential and another one is kinetic. And one is, you can say it as EP, energy, potential, EP. And the second one is EK, energy, kinetic, EK. So EP and EK, both are the energy and both are also in the formation for work done. But if we talk about the energy and kinetic energy, potential energy and kinetic energy equation, potential energy you can describe it like this way, just like this, mgh. But kinetic energy, we have some different equation, half mv square. And you will get it when Rofik sir will teach you about this. Okay. So these are the things we have to, these equations we have to apply when we are going to get some power. All of these equations, just like this 4. W is equal to MAS, W is equal to MGH, EP is equal to MGH, EK is equal to half mv square. All of these 4 equations you have to get first when we are going to solve some power mathematics. Okay, now we can solve some math of it because we can see some equation on the board and we can apply it. We know about the quantities. That's why we can do some power mathematics now. Okay, start with it. An object of 10 kg, an object of 10 kg mass is taken to a height of 5 meter, is taken to a height of 5 meter in 4 seconds. In 4 seconds. I repeat again. An object of 10 kg mass is taken to a height of 5 meter in 4 seconds. Calculate the power. Calculate the power. So, which equation we will use? First, we have some. We will use some memory, or we will look into this equation. W of mgh and EP is equal to mgh. So, which equation we can use now? You can use the both of it, but you have to use the equation W equal to mgh because I am going to take this object, 10 kg object, from downward to upward direction. That is some vertical thing. So when we're doing some vertical work done, we must have the work done as mgh, or the potential energy also mgh. So you first get the value of W or the value of EP first. So what you are given here, M as 10 kg. Also you are given height as 5 meter. Also you are given time as 4 seconds. And you know that G as 9.8 meter per second square. So putting all of these values into the equation W, you can solve the value of P. So first you will get the value W, which is mgh, and after that you will use the equation P, which is W by T. So first use this one, and after that use the equation P. You will get the answer. Follow.
Sir, what is the unit of work?
What is the unit of work? It's joule. It's joule. I already told that when I give the definition of power. Use the calculator. Use the calculator, use khata, pencil, pen, all of it. Because it's a class and you are using, we are just virtually present, but we are doing the same thing that we will do at the school or colleges. Okay. Any of you can say the answer?
Sir, 98.
Sir, 122.
98 watt? Is it watt?
Sir,
Yes.
122.5
Yes, sir.
watt.
Sir, 122.5.
122.5 watt.
122.5, sir.
122.5.
Okay, so J 98 bolte so just check it again whether it is you are doing some
স্যার
mistake
এখানে
on the
অ্যানসারের ইউনিটটা কি হবে স্যার?
watt.
Watt.
You know that the unit of power is watt. You have already written on your khata. The unit of power is watt. W. there will be a confusion here. You express work as W and the unit of power is also W. So these two W's are not the same thing. One W which represents work is the denoting sign of work, but the second W is the denoting sign of watt. So these two W are not same. You have to remember these things. Okay. So if I say just like this, mgh by t, so m can be said as 10, g is 9.8, h is 5, and this is 4, and you say that it is 122.5 watt. Okay, so 122.5 watt is the answer. Okay, the first math is finished. Now the second one. Now here we go for the second one.
Sir, shouldn't we convert kg to gram?
kg will never be converted into gram when you are doing some physics math, because kg is the SI unit and gram is the CGS unit, and you have to convert all the things into the SI unit, not in the CGS. So you have to remember this thing also. If you are given gram, you will convert it on kg, but if you are given kg, no need to conversion, because kg is the SI unit. And also the same thing, if you are given minute, you have to convert it on second. Hour, second, you should convert it on second. Okay? Then now we will go for the next one. Sorry, a 5-ton truck. A 5-ton truck has uniform velocity of 54 kilometers per hour. A 5-ton truck has I'm sorry, I'm going to again. Most of you can't hear. A 5-ton truck has the uniform velocity of 54 kilometers per hour. 54 kilometers per hour. What will be its kinetic energy and power? What will be its kinetic energy and power if the truck achieved this velocity in 1 minute? If the truck achieved this velocity in 1 minute. If the truck achieves this velocity in 1 minute. So you have to get two answers here. One, I am giving you to get the kinetic energy, and the second one, the power. So first you will go for the kinetic energy, and then you will go for power. Because without work or energy, I cannot get power. So first you have to go for energy first. So which equation I can use? I am watching some equations on the board. Now that I have kinetic energy to get, so there is only one equation for kinetic energy written on the board. That is Ek equal to half mv square. What is m here? It's 5 ton. 1 ton means 1000 kg. So 5 tons is 5000 kg. First one. And then it has a uniform velocity of 54 kilometers per hour. It will get a uniform velocity of 54 kilometers per hour. So how we can solve 54 kilometers per hour? It has m of 5000 kg and the velocity is 54 kilometers per hour. So you can multiply it with 1000 and divide it by 3600. It becomes meter per second. We know that how to convert kilometer per hour into meter per second. Multiply with 1000 and divide with 3600. So you will get the answer, and it will be more or less 15. It's 15 meter per second. 15 will be the answer. So first you will get the kinetic energy. It's half mv square. And then you will get the power. It's Ek by T. You are using Ek by T. No confusion here. You can completely you can say this equation Ek by T, because Ek, W, Ep all are same in some prospects. Okay. Anybody? You can give me the answer.
56,000 to 55 lakh 6,000. Sorry, 5 lakh 62,000. 5 lakh 62,500 joule kinetic energy, and power
Okay,
is
so the
9375 watt.
kinetic energy, I can say that the kinetic energy as 5,65,500.
62,000.
Sorry.
No, 5 lakh 62,500.
500. Okay, that I can remember that. 5,62,500 joule. Like this one.
And power is 9,375 watt. 9,375 watt.
5,375 watt. Okay.
9,000. So 9,375.
Okay, so I mean, লিখে দিলাম 9,375 watt.
Sir, velocity
This
conversion
is the power of the truck, and that is the kinetic energy of the truck when it has a kinetic energy after 1 minute. It's 5,62,500 joule. So
Sir,
you
velocity-
have to remember. Yes.
Sir, velocity conversion টা একটু দেখাতে পারবেন sir, kindly?
Okay.
Yes, sir,
So
54K.
it's an easy one. If you are given something like that, 36 kilometer per hour. If you are given just like this, 36 kilometer per hour. So it's kilometer. Kilometer, you have to convert it on meter. So you can multiply it by 1,000. So this is meter, but this is per hour. What is 1 hour? 1 hour is 3,600 seconds. 1 hour means 60 into 60. You can say it as 3,600. So this will be the conversion. If you are getting 36 kilometer per hour, you are multiplying it with 1,000 and dividing it with 3,600. At that time, you can say it meter per second. Kilometer is converted into meter and hour is converted into second. Okay, good. Now, I am giving you another math. The power section contains more math than any other section, work, energy, any other section, because power is included with work and energy. So the next math comes. A stone is released. A stone is released from 39.2 meter height. From 39.2 meter height, and it hits the ground, in certain time, and it hits the ground in certain time. If the mass of the a stone is released from 39.2 meter height, and it hits the ground in a certain time. I'm not giving you the time. I'm just saying that it hits the ground in certain time. If the mass of the stone is 200 gram.
কোশ্চেনটাকে আবার রিপিট করতে পারবেন?
হ্যাঁ পারবো। তোমরা কতটুকু শুনছো বলো তো?
The mass of the stone.
ওকে, সো আবার আমি ফার্স্ট থেকে বলি, যারা শুনো নাই বা যারা শুনতে পারো নাই তাদের উদ্দেশ্যে। A stone is released from 39.2 meter height. It is released from 39.2 meter height and it hits the ground in certain time. Full stop now. If the mass of the stone is 200 gram, what will be its power when it hits the ground? If the mass of the stone is 200 gram, if the mass of the stone is 200 gram, what will be its power when it hits the ground? So here you are given some things, just the mass 200 grams, you can say it as 0.2 kg, and also it is released from a height of 39.2 meter. It is released from 39.2 meter and we don't have time yet and we have to get the value of P power, and we don't have also the work done or kinetic energy or anything of it. So I can say work done. We don't have any work done here. Okay, I'm just getting blurred. Okay, now it is clear. Okay. So how you can solve it? We have mass, we have height, but we don't have time, we don't have power, we don't have work. Okay, work can be determined using equation W is equal to mgh. So first you determine the work done. What will be the work done? What will be the work done? mgh.
$76.83.
Okay, so it's 0.2 into 9.8 into 39.2, 70.
76.83.
76.832.
Okay, so 76.82 will be correct. It's Joule, W. And now we don't have any T, but we can use an equation just like this. We know this. H is equal to UT plus half degree square. You see, you can't escape the equations for motion. You have to use this equation in several mathematics. Now it is 39.2. We know that the falling object has initial velocity of 0 and half into 9.8 into t squared. So you can say the value of t here. What is the value of t?
$2.83.
2.83. Now you can easily get the value of P because you have W, you have T. You have W, you have T. So you can easily get the value of P. Just divide the value of W with T.
$27.15 power.
27.15 watt. Sorry. 27.15 watt. Okay. So these are the answer. Okay, boys. So today we will discuss topics about power, but power isn't finished yet. We will discuss it the next class tomorrow. The next class when we get the next week, in fact. And if you have any problem in work or energy section, then you can discuss with me in the next class, next session when we are going to go going our topics of power. Till then, all of us will definitely learn about these things. Okay, thank you. Is there any question, or then I will stop the meeting for now?
So can you please say the last part of this question?
Which one? This mathematics, the last mathematics.
Yes, sir.
What will be the power of the stone when it hits the ground? What will be the power of the stone when it hits the ground? That will be the last part of the question. Okay, boys, thank you then. আমাদের তাহলে আবার দেখা হচ্ছে আগামী উইকে। সবাই ভালো থেকো, সুস্থ থেকো। আল্লাহ
আসসালামু
হাফেজ।
আলাইকুম স্যার।
ওয়ালাইকুম সালাম।
আসসালামু আলাইকুম।
ওয়ালাইকুম সালাম।